name is Michael Murray. I'm the General Manager of Industrial Sensing and Analog Devices. IDS is actually two businesses, thanks. One is smart city, smart infrastructure, smart agriculture, which I love, and smart buildings. The other is high performance inertial, building things like magnetometers, accelerometers, and gyroscopes, and this thing that we call intelligent sensors. So my friend here, Francis, will walk you through our journey in tomatoes. They're not necessarily machines, but they're now connected too. So, Francis.
Thanks, Mike. So I guess, yes, I'm the agricultural interlude in the afternoon here. And then, what I'll represent this afternoon is, I guess, more the market side, if you want to think about it. I come from, I'm a peasant from Eastern France originally, and I run an agricultural business, and I'm also a repented academic and consultant, and which is why I like to walk about, I guess, a little bit here rather than sitting on a podium here. So my role will be to describe what we're doing with this project called the Internet of Tomatoes, and Mike will describe much more the technical side of things, probably the things that most of you are most interested in. So let me describe very, very briefly what we set out to do with tomatoes out there. We started by looking at this as the tomato market and deciding that it is a fairly inefficient market. If you take a look at this picture here, I don't know whether that's visible in the back there, but just the whole tomato global supply chain is not a particularly efficient thing. If you look at the market today, you'll find that in developed countries like the US or Italy and Spain, which would be other big markets, tomatoes tend to be very affordable in general, not necessarily of great quality and not necessarily of terrific sustainability. They come a lot, as you'll see in a second, from areas without water, without soil, and so on. So generally speaking, the data about tomatoes is quite opaque, and we began becoming interested with Mike and the ADI team, Analog Devices team, into what would it take to make that data a little bit more transparent. Western countries or developed countries have this problem. Emerging countries have a different problem, which is essentially feeding everybody. So as you know, we're trying to feed 9 billion or 10 billion people. We estimate that probably 60% of the production will have the jump in productivity needs to be about 60%. And we think the Internet of Things has a very important role to play in all of this. So we started with this giant picture, and since we're both Boston-based, we said, well, probably a good starting point is to start very locally. We use this approach called co-creation that says, how do we build ecosystem? We need to start with this broad vision that we try to describe on this slide here, and then said, why don't we start with a very, very focused kind of bottom-up view of the world, and let's see whether we can transform the tomato market in New England specifically. So with that in mind, we got started, and we said, well, let's start in Boston, since we both happen to live in Boston. It was an interesting conversation at the table out there between the rivalries between the Montreal Canadiens and the Boston Bruins, because we have some Canadian people out there, but we settled that rapidly. So started in Boston. And the first thing that you learn when you start becoming interested in tomato is that people think that tomatoes taste fairly badly. They taste like chalk. Generally speaking, people are not very excited about tomatoes, except in a few cases. But generally speaking, the quality of tomatoes leaves a lot to be desired. If you look at really how tomatoes are grown, and I always get a little trepidation when I describe this type of stuff in Florida, but just because Florida is essentially the center of the fresh tomato market. But a lot of those tomatoes start as really being essentially harvested very green, right? They're grown to be harvested very, very easily and transported very easily. And then over time, those tomatoes tend to be ripened using ethylene gassing. Right? So they don't ripen on the vine. Typically what they do is they are essentially gassed along the way in various distribution areas. And that's why typically people are critical potentially of the taste of that. If you take a look at the environmental record of this, you'll find largely the same issue, which is, if you take a look at the processed tomato market, about 80% of the market is processed tomatoes. It's tomato sauce and pizza sauce and V8 juice and Campbell soup and all of these things. About 80% of that market comes largely from California, right? California is the center in the United States of really the processed tomato market. And there is one resource that California doesn't have, and that's water, as you know. And tomatoes are heavy consumers of water. So there again, the idea is not to indict California production, is to try to figure out how we can do it with less water, how to use, in essence, data to optimize the growing of the plant itself, as well as the irrigation that is associated with it. By the way, both Florida and California have some very valuable assets, which is the weather, right? And it's just obviously a whole lot better in those two regions than in lots of other places. So Florida doesn't have a lot of soil. That is one of the limitations associated with that. So that set constraints also on what it can do. And there again, that factor is not necessarily taken into account in the optimization of the growth of a tomato. So there again, from an Internet of Things vantage point, we think there's a certain amount of capability that one can change, one can fundamentally change the nature of the equilibrium that one creates between essentially the economic imperative, which today is very well served by the economics as we have them. The yields tend to be fairly high, at least in the US. The quality is more debatable, and the sustainability record is less so. So what many people believe will happen, and we are part of that school of thought, if you want to think about it that way, is that we think there will be a rebalancing that will happen over time of that supply chain, a rebalancing between the raw economics of the value chain and what is going to happen on the quality and sustainability side. The background of all of this is also food security or food safety, which is obviously of paramount consideration, which is even a Uber issue if you want to think about it over and beyond productivity, quality, and sustainability. So there's also some issues associated with really the labor practices and the environmental record of some countries. If you take a look at the US market, California and Florida are the two major producing countries. Canada in the north and Mexico in the south are the number 3 and number 4 producers. So there again, there are some issues associated with basically labor production and environmental record out there. And we think there is a way of capturing that within the tomato itself. The tomato has a health record of its own, very much like there's a human health record, right, or an electronic health record for a live patient. The same is true for a tomato. And obviously the ambition is to be able to diagnose that in the tomato itself. There's also a very, very militant movement in most parts of the world, and that's particularly true in the various regions of the US, to help local production. So there's a lot more of democratization of the production of tomatoes going on. The local producers essentially are developing, very often it tends to be more specialty tomatoes, right? It's where heirlooms tend to fit in and so on. So that allows there again the development of an indigenous production, which again tries to prove its own quality, and they, those farmers are trying to aggregate, own their own data, and begin to engage the sensor manufacturers and the IoT technology developers into essentially building the case for local production. So we are actually quite agnostic on whether the local people should win or the big central production should win. Obviously, our role is to make that data transparent. The role of analog devices is to create that data, operate the cloud that will allow, in essence, the chips to fall wherever they may. So there's also, the belief that we have is that the transformation of the agricultural and food chain will come in bottom-up fashion. There's a lot of efforts right now coming from essentially the big seed manufacturers, crop protection companies who want to do things top-down. They want to own the data. They want to create the agronomic recipes and the seed developments and so on that will allow that development to take place. We think that eventually the winning combination is going to come from the IoT suppliers, the sensor manufacturers, the algorithm developers, and so on, who will essentially democratize the data by creating aggregations of probably farmers and consumers coming together. And by giving them the tools to essentially aggregate that data, this is where a lot of the value will come from. A lot of the value will not come from big data initially, will come from small data. There's a lot of productivity reserves or reservoirs that exist at the very local level. So, Mike and I and various other people believe very much in the power of that really small data initially. And of course, as you aggregate it more and more, the recipes become more and more universal, and the gains in productivity can take advantage of really looking at that big map of tomato production and so on. So the challenge of the local production is that they are obviously typically of high quality or of better environmental records. They tend to be, having said that, reasonably expensive. So it's kind of a cottage industry today. It's kind of an industry for rich suburban people, in essence, or fairly affluent suburban people. So the name of the game is to create something that allows to rebalance everything between essentially the commodity industrial market on one side and the specialty, high quality, highly differentiated view of this. So what we're trying to work together on with my colleagues from Analog Devices is how do we essentially allow the supply chain to become more transparent collectively and encourage this redistribution in both Western countries or developed countries and emerging countries. So with that in mind, maybe I'll hand it over to you, Mike, and start talking about what we're doing technologically speaking.
So one of the things that I like to start off with very quickly is people always ask me, analog devices, what the hell are you doing? Why are you here? Don't you build analog devices? Well, the answer is yeah, we do, but we also build cloud services in complete systems. I've instrumented fabs. I've instrumented the Cybersecurity Agency of Singapore. We have machine learning sensors. I have a full algorithm team doing Bayesian math. But what the hell are we doing with tomatoes in New England? Well, quite frankly, this is IoT at its very simplest. I was at a meetup. It was last week, actually, and I met Mark Bernardo from GE. And he asked me a question. He said, how do you get started in IoT? How did you get started? And I said, we started very simply. We just started. Two of my guys came in, and in fact, I'll show you a picture of them. And they had this crazy idea that Francis and Robo and JP came up with was, how do we find the answer to why? Why do tomatoes from New England just suck? They taste horrible. Well, that's the question that we started with. So 55 minutes we spent kicking it around, thinking about why are they so bad. Then the other 5 minutes, we actually crafted out on the back of a napkin, hey, we can solve this in 5 minutes. It was the question that took us the longest time. So in IoT, it's all about the question. So the question in this case, how do growers in New England understand what happens with restaurants and chefs and you folks that actually eat this stuff? How can I take that information from New England all the way to your plates and get feedback from you? Well, the answer is actually that's very difficult to do. But unless you put your boots on, you go out to these 5 farms in New England and teach these farmers, who, by the way, are very competitive, very intelligent, and they are technology savvy. Don't kid yourselves. These people want to know how 1% productivity will add to their bottom line. 1%. They live and die by 1%. Do you think they're aggressive? Yeah, they are. So we challenge them to say, we want to take your information, we want to study it, and we'll be able to tell you how a better tasting tomato actually hits a consumer's plate. And the answers that they gave us were absolutely astronomical. So this was our journey in IoT, and this is why I think it's so cool. We started with the farmers, and there's our happy farmer up there. He's wonderful. He's picking a lot of tomatoes. He has no idea what actually ends up. They might go into paste. They might go into a restaurant somewhere. He's not really sure. All he knows is he's got to sell his tomatoes. It's no different if you said that was a widget, a cloud service. It doesn't matter. You're building something, and you've got a consumer down the way, right? Very simple. So we looked at what we needed to understand, which was what diseases, the yield, water levels, heat levels, soil pH as an example, what light is available to these farmers. In New England, we have weather every 5 minutes. Just wait, it'll change. So all of these things impact the growing season. And then when to harvest. Obviously, this is something that's very dependent upon weather as well in New England. So my team and I, we built a little thing called Fenway. We called it Fenway because it's green and it's ugly, just like our ballpark, which is basically a sensing pile. So we have impedance sensor, temp, humidity. We have some mass spectrometer, a little microcontroller, an optical controller, as well as some Bluetooth radios. And we built a little moat. That's all we did. Cost me less than a couple $100, okay? Then we connected to our friendly iOS app store, and our friends over at PTC were kind enough to give me access into their cloud, and we built a little mashup using ThingWorks, which actually is pretty sweet. We actually showed that at Let's Talk About Food, and I think at LiveWorks we actually showed it as well, which was kind of cool. And then my guys and myself decided I like to cook. I don't know why, I'm horrible at it, but I make a lot of pasta. I'm English from Canada. It's horrible, but it actually got better as I started to try new tomatoes. But I tried this, and we actually built a tomato sauce, believe it or not. So what we had to do was really understand the temperature, root stress, all the gases that go along with a greenhouse as an example, and there are many. We also looked at humidity and soil condition and leaf stress. And this is our little moat that we built over here. So we took aggregate data through Bluetooth to a concentrator, then ISM band transceiver out, okay? Pretty simple, not that difficult. So this is the board. One of the interesting things that we ran into is that growers, when they go out on the fields, they don't necessarily want to carry a bunch of equipment with them. Makes sense. Farmers don't really want to have things strapped to them, nor do they want to have an ecosystem sitting in their farmers' yards for things to be hit or run over by tractors. So we basically made this just a coin cell operated main board. This is a Cortex M3 device. It's just 16 megahertz with a 16-bit A to D on it. We also did a load side switch just to turn the board on and off very quickly, so this thing will actually last an entire growing season without having to recharge it. By the time it's done, you throw it away, okay? So we also connected a sensor board. These sensor boards are really important to understand. Each sensor card is actually adapted to a different type of agriculture application. In this case, it's tomatoes. We also have a sensor card for grapes. We also have a sensor card for tea leaves in India, which I'll get to in a second, because those cards need to be different. But all the software is actually resident in our friends at PTC in their cloud. So when they connect through their cell phone, they can actually flash the card, get their data, and actually build a mashup right then and there, depending on the produce that they want to sense. That's very important. So this card, roughly speaking, it's a couple of bucks, not a big deal. This card, again, a couple of dollars. Now, what I will say here, and more specifically that we had to get through, and actually we just had this conversation at our table over here, this is a better together strategy. Not one company, whether it be Analog Devices, IBM, GE, can do it on their own. So instead of using my crappy little Bluetooth part, we actually used a dialogue part that was a lot easier to use and lower power. In this case, we also used a Honeywell humidity sensor, and Honeywell and PTC, as well as Dialog, are partners in this project, along with our dear friend Francis here. Okay? So, what did we do? We went off and we destroyed a whole lot of tomatoes. We made some sauces. We actually took this to MTech. We took it to Let's Talk About Food, and we have a celebrity chef actually make sauce with the tomatoes that we scientifically proved tasted better than the other ones. Not bad. And I myself actually had the jar of Analog Devices tomato paste, and I used it, and you know what? It wasn't that bad. It was actually pretty good. So these are my guys. This is Robo, and this is JP, demolishing a bunch of tomatoes, and that's for the 31st Boston Tomato Contest, where we want to be able to predict the best tomato that will win that contest. And now we have a scientific model that is now resident in the cloud that folks can go take a look at to understand what the lycopene levels, what the sucrose levels are of the best tasting tomatoes in New England. So scientifically, if you want to build a pizza, as an example, using a sauce that's a little bit more tart because you want to have that mix a little bit better, I can tell you which tomatoes to use. If you want to build a tomato paste for things like your pasta, I can also tell you that. So scientifically building up a data model. So in Boston, we have some of the best tech data houses around. We've got MIT, Analog Devices, GE's just putting their new corporate headquarters there down in South Boston. Our friends over at PTC, MathWorks, you name it. We've got a great little ecosystem here for IoT. We have some of the best food already in the place, but we didn't necessarily have the best agriculture. So that's our new journey here, is to make sure that New England has some of the best agriculture, scientific agriculture on the planet. So we're ready to take this a little bit bigger. We started off very small with 5 little farmers in New England with a big idea and a couple of grand and a small little Cortex M3 board. That's it. But that data model that we're building is worth a lot of money, number one. Number two, it can solve a lot of problems. I presented this to the president of Fujitsu, and he's flying me out to Japan to do this exact same talk for the rice growers. Right? Rice, one bottle of this premium sake that they produce, $1,800 a bottle on a square kilometer of rice. They get one bottle. That's it, one bottle. And that was given to the President of the United States, by the way. So if I'm able to solve that problem, I'm sure they might send me a shot or two, but we'll see. India, I want to talk about India for a second. So India, right now, the amount of suicides in India have risen, I think, 32% in the last decade. And the majority of those suicides are farmers. The reason why is their entire profit margin is around 3 to 5%. So when they lose the crop, they have nothing left. They commit suicide. So thinking about this for a second, if we're able to improve their profit margins by 1%, by math, I should be able to save some lives, right? Using this small little board that costs next to nothing. So we're working with Tech Mahindra. Mahindra makes farming equipment in India. I think they're one of the largest companies in India. So we're working with them to proliferate this message and help educate their farmers on how to use this technology to improve their yields. So small little example. I was originally going to come here and talk to you about 4 to 20 milliamp loops, HARP modems, and how we instrumented our Limerick fab, and how to use my sensors for things like Bayesian control and predictive analytics. But instead, I wanted to talk about this because this is how you start in IoT. I think it's a great story, and it's something that we want to take a little bit farther. Francis, do you want to?
Maybe add just a couple of things. Maybe we have 5 minutes for question or something. But just so the thing that I wanted to salute here is kind of the way analog is going about doing this, right? The traditional development model is you find a big user. So in agriculture, you'd go to John Deere, you'd go to Monsanto, you go to the big food company, Heinz, and other people, and they obviously have a key role to play in all of this. And the classic funding model is to do that. That requires typically a lot of infrastructure, very fast, a big contract, and getting started. So what we're experimenting with Mike here is this notion of just creating a bottom-up aggregation model, because in essence, we are starting with those farmers and those chefs and those consumers, which is a very fragmented population. We think there's actually a lot of value in those sort of regional aggregations. Doing tomato in New England, when you look at it from a corporate strategy standpoint, is not going to be the biggest market you're going to find, instantaneously. So what we're trying to do is create this kind of piece-by-piece aggregation of that data, and that is rooted in a philosophy that says, in essence, the entry cost into the IoT stuff should be reasonably low, number one. And number two, there's value immediately in doing that. As Mike just explained, when we went to the Boston Tomato Contest, we had something like 100 farmers who were there, and we tested 300 tomatoes. Immediately, they started bombarding us with questions about whether they should have picked that tomato the day before or the day of the contest to maximize their sugar level or their acid level, and so on. So that is the discovery process that allows us to hit a lot of singles, I guess, very, very early on, and then begin to aggregate everything. We both believe that eventually the win is going to come from this very patient aggregation of things. And that's even more true when you go to emerging countries, where by definition there is not a whole lot of big players that are going to come top down and doing that. So the view is really, it is bottom up. We're interested in creating a very sort of bottom up view of the transformation of something like the ag food chain here. And we're trying to create it, in essence, starting essentially with this democratization of the data and providing the infrastructure required for that. So Greg, I don't know, do we still have 5 minutes for question? Yep. Okay.
Sure.
So how long did it take you with the tomatoes to get that data to get the best tomatoes?
Can you just repeat the question?
Sure. So the question was, how long did it take us once we got the data to understand what is the best tomato? Did I capture that right?
So doesn't it take more than one growing season to tweak all that data?
It does. Great question. Fantastic question. So we have a growing season. And essentially what we had to do was destroy a lot of tomatoes, for lack of a better term. So you're exactly right. We had one growing season. We understood the scientific values within the tomato, and then we basically conjoined those with taste, right? Now what we're going to do is we're going to go through another growing season, and we can actually start at the seed and understand what the pH of the seed is, the pH of the soil, et cetera, and then we can confirm our hypothesis once again. So essentially, in my math, it actually takes 4 growing seasons to get a really strong model. 3 to 4. In New England, it's probably going to be closer to 5. Florida, you could probably do it in 3, just because the stability of the environment. But that's a great question.
If I build on Mike's answer as well, another key element here is to start with a finished product and working our way back into the lead indicators. So the reason why we got people interested early on is just, we started measuring the quality, which is not an IoT application per se, and we did it, as you saw, with fairly invasive or destructive technologies. But that created the questions that allows us to move back to the lead indicators, as Mike just explained somehow. So starting with the end product has been helpful.
Now, actually, going back to that, and thank you for that, it'll be interesting to see what the growers do. Right? Because now they've got a target market they can actually fixate on. So if they have more sweet tomatoes, they might go for a tomato paste type of end market and choose their growing cycle and their seeds a little bit differently and water a little bit differently. So it's going to be interesting. I think this isn't done. Let's put it that way. We're getting bigger. We're growing it, and we're getting more data, and we'll see what the outcomes are. But again, we started with the question: why do they just not taste that great? And we've been able to scientifically prove which ones taste better. Now it's all about making it repeatable, to your question.
Other questions or remarks? Guess I'm not interested in agriculture.
Well, I mean, the thing that...
Hold on. Give the mic.
The thing that's going through my mind is, so you take that first season and you can kind of get all your kinks out. But then in my head, I'm thinking, then that second and third season from a building management process, that would be when you're starting to be able to head towards your predictive and preventive maintenance. So,
Yeah,
yeah.
you bet. No,
But
you're
it does
exactly
take
right.
those first couple of seasons to get those kinks out. So I think
right.
this is wonderful. This is actually.
That is true. So there is a transformative dimension as well in here in the whole agriculture chain, right? Because right now it's a commodity kind of thing, right? So a tomato is a tomato because we don't know its quality, inherent quality. The moment where we start having those ADI sensors in there, you begin to distinguish between this. The farmers are beginning to think, you know, at my farmer's market, I can probably get $5 a pound for this one versus $4 a pound for this one because the sugar and acid content is higher. And then through that, you can get into, you know, we're beginning to talk to people like Cargill and ADM and other people who are interested in decommoditizing the tomato market, if there is such a term here. It's from the old French, to decommoditize, or something.
Okay, we can take one more question if you want, or?
Yep.
There we are.
Gentleman here.
So maybe the obvious thing here is, okay, so you developed this for New England, and you're developing this model. And then, but as in prefacing this, you talked about California, you talked about Florida, you talked about other regions, you talked about issues with water, you talked about issues with soil. So once you develop this model, then isn't the idea then to be able to take this and adapt the model to all these different regions and conditions and so forth going forward?
Right.
Yeah, they'll
And giving those folks the same advantages and so forth
exactly right. So
in their situation.
there's going to be data sets that come out of this where there'll be a set of models that we need to have for areas like New England, right, that are just more focused. So our goal is to have one large data set, right, a number of N's that we can run algorithms on, just the amount of data, the big data out of all the little data. And our goal is to take small data sets out of that, so that if you're in a New England type of area or Eastern Canada, the soil is somewhat similar, the weather is somewhat similar, and we want to focus that down even farther so we can run more finite algorithms on that to understand it a little bit better. Whereas you look at California or Florida, it might share a little bit more reasonable type of data models because of the climate. So we're going to look for those correlations in the data, but we're not there yet. To your point, that takes a couple of growing seasons and a little bit more numbers of data sets to be able to pull that off. But ultimately, that's the goal, and we've built some models already. In fact, we can actually segment New England, which is really interesting. I didn't think we'd be able to do that. We're also working with shellfish as an example. But ultimately, that's the goal, is to have individual data sets for individual climates for individual types of tomatoes.
And the data structure can be the same. It's still a variation on, you know, safe, affordable, nutritious, tasty, and environmentally sound, right? But just the mix is going to change by data set there.
Yep.
Very good. So
Okay, well,
thanks.
thank you very much.
Right,
Thank you.
Thank you. Thanks. Yep.